Now we come to the real thing, the discussion that we wanted to do for the discussion regarding mass, Bernoulli's equation, and energy equation. So all these equations within themselves express conservation laws of conservation in nature of these quantities. And of course, from where possible, I try to give examples also, so that for you also it is important to realize and see how important is a particular thing that we are discussing and where we are applying it, and so on. So these are, for example, for some time, for the last 15 to 20 years, there has been great enthusiasm among scientists to conserve energy and to get somehow independent of energy that is produced from oil or coal, because not only that, because they feel that it spoils the environment, they also want clean, neat energy that is cheap also, that is not as expensive as these two forms of energy is, because the prices of oil at times keep going up and so on, and the coal is very hazardous to the health. So there is a great effort to produce energy that is renewable, that we can renew without creating anything in space or in our environment that spoils its cleanliness, that makes it harmful to the health. And for this purpose, one of the things is to create windmills, forms of windmills that use the speed of the wind and transforms it into electricity. So that, for example, is a good example where in the designing of windmills that we see every now and then in the forms where these windmills are being erected and used, the Bernoulli's equation is very much used in its designing in the initial stages of this kind of forms. So Bernoulli equation, you may see in the end when we derive it, looks very simple, but it has important application. Even today's new aspects, new things that we are doing, although the equation was developed about over 200 years ago. The mass, energy and momentum and angular momentum, all these balances are utilized in the design of turbines. The Bernoulli equation is also used in preliminary design stage. So all these things are related, and not only related, they are used. So turbines also, we use them in the development of turbines, and also in windmills and so on. So you are already familiar with conservation laws, because we start studying from the very beginning. As soon as we are introduced to science, the more well-known names are laws of conservation of mass, law of conservation of energy, and law of conservation of momentum. Traditionally, the conservation laws are first applied to a fixed quantity within a closed system, and then it is extended, it is generalized in the space. Many fluid flow devices, such as this Pelton wheel hydraulic turbines, are analyzed by applying the conservation of mass and energy principles along with the linear momentum equations. So all these equations, all these laws are even, I am giving you here an example. Earlier I gave you an example where Bernoulli's equation was being used, the designing of the windmills. Here is an example, and I mentioned that this is also used in turbines. So here I am giving you an example where during the designing and analysis of the turbines, such as this, what they call as Falcon wheel hydraulic turbine, these rules are applied, the laws of momentum, the laws of mass, the laws of conservation of energy, and so on. And this is an example where I have shown you the turbines. The conservation of mass is a relation again within the enclosed system, and it is supposed to be, the law says that the mass is conserved, that is, the rate of change of mass, there should be a dot here, is constant, and if it is constant, then its derivative is zero. If the mass is, if the total mass remains constant, then the rate of change of that mass, which is constant, must be zero as indicated here. So this statement is really again re-emphasizing the law of conservation of mass. When we write it in mathematical terms, we use these equivalent terms from time to time. Conservation of mass can be shown as the law that the rate of change of flow of mass that is coming in minus the rate of change of mass of fluid that is going out of a particular system are equal. That is, their difference should be constant. And if it is constant, then we know that the derivative of a constant is zero. So we write it as dmCv over dt, and this has to be then zero, or this is shown by the total rates of mass of flow into and out of are obviously shown by these equations as above. They are shown here as well. And similarly, the rate of change of energy in the same way will be shown as dE in the control volume in the same way. In fluid mechanics, the conservation of mass relation written for a differential control volume is usually called continuity equation. So, the conservation of mass equation sometimes is also known as, another term we use for it is what we call as continuity equation. And we use this continuity equation very frequently in the solution of our equations of motion whenever we are analyzing a particular flow that is flowing. So here we are just mentioning it in the passing, but when we discuss Navier-Stokes equation or momentum equations and so on, then we shall be talking about continuity equations in more detail as well.